Good morning. Testing in you, the perfect pair. Testing in you, the perfect pair. You could say testing is your dream lover or you belong together. But today we will be talking about testing. Now you probably came to Turing School of Software and Design because you wanted to be like, hey, instructors, teach me how to do stuff. Which totally makes sense. But this morning, you're going to teach me about how RSpec works. A few things before we start this lesson. Testing is, well, with a lot of things in programming, it's a difficult concept to grasp. But hopefully, we can break it down to its smallest parts. And you can understand, one, why testing is important, and two, how to write a test for your code. Does everyone have the Ruby exercises repository cloned on their computer? If not, I would take the time to go ahead and clone that repo. And that exists here. Ruby, oh shoot. Let me pull it up. Ruby exercises. That exists here. If you don't have it yet, I'm gonna paste that in your thread. There you go. You need to clone that down. I'll give everyone like 30 seconds to go ahead and clone that down. Mitchell, what's your question?
If this was cloned down in the past few weeks, did it change to RSpec or something? Didn't something change in the exercises? Do we need to reclone it is what I'm asking.
Did it change?
Yeah.
Yes, I think it did.
Very different.
Okay,
so we need to redo it. Okay.
Yeah, I would clone down this new version of Ruby exercises. You are the lucky guinea pigs. We are moving away from mini tests of module 1 and we're moving to RSpec. Now, why is that? RSpec is the quote unquote industry standard when it comes to testing in Ruby. And so we figured we would just teach you RSpec from the beginning. And so all the repeaters get the fun activity of learning a new testing framework. So take time to clone that down when you get the chance. Give everyone a little bit of time.
Hey, is that going to erase all the work we already did?
Yes, it might. So maybe clone it down to a different subfolder or directory. Would be my recommendation. You could delete your old Ruby exercises if you want to.
You tell us how to clone it to a new directory?
Sure, I can do that. Basically, okay, I'm in my root directory right now. And then if you hit ls, you can see all the folders that are in my root directory, right? So let's say you had your Ruby exercises in the root directory. You could just like make a new folder and put it somewhere else, basically, right? You can go make dir other folder or something, and just clone it down inside that one. As long as it's not in the same root directory, you should be fine. So that would be my suggestion. Okay.
May I ask a question?
Yeah, go ahead.
If I already deleted my old one, is there any way to get it back, or is it's gone forever? Probably.
Does it live on GitHub somewhere?
Maybe.
GitHub being the cloud internet.
I don't think I ever uploaded it to GitHub because I wouldn't have had a reason. It was just on my Atom.
Okay, it's not a huge deal because Ruby exercises are more for your own sake, right? So whatever.
The ones are gone, they're gone.
Yeah, I mean, there is probably a way to get them back. No, it'll be tough.
Okay.
Yeah.
Okay, thank you.
Okay.
And well, sorry, my real question though is if I wanted to get the old Ruby exercises back again to go through the walkthroughs and just to get the methods, like, you know, just to have those concepts and practice those concepts along with Josh Thompson's walkthroughs, that makes sense in the way that he's talking to, or referring to them. is there any way to get the old Ruby exercises downloaded again?
I think the new ones are exactly the same. We just have an updated testing framework. So
so it looks very different to me, but maybe after the lesson today, it'll make more sense.
Okay, cool. Yeah, the testing portion will absolutely look different. Cool. So we're in Ruby exercises right now. And where are we? We are in data types, collections, spec, array spec is the file we are in. Then let me just show you how to run tests in RSpec. Basically, use the rspec command, and then the name of the file that you want to run that test in. In this case, it's in data types, collections, spec, array spec is the file we want to run. So you need to do gem install rspec if you don't have that already, but this is how you would run that file. So I'm going to go ahead and run these specs, and you can see a bunch of them are skipped because they're yellow, and it says temporarily skip with exit basically. And the only one that's not skipped is the very first one, which is failing for us. We have one failure and a bunch of skips indicated by these asterisks. It says name error, undefined local variable or method underscore, 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 underscore. So what the test is asking us, or the assertion, it says we expect empty, the variable empty, to be equal to an empty array. And then so how we make this test pass is we just assign the empty variable to a new empty array. And we can run our test again. I'm just showing you the mechanics of it right now. And then we can see our test passes, right? We have one passing test. Then to unskip the next test, you have to delete the X. And that will run our next test first. I will run the test file again. And you can see that arrays test1, this is test1, is failing, basically. So you need to delete the X to unskip the next test. And it's important because you want to pass these tests one at a time, basically, one at a time. All right. This is what I'm going to have you do in breakout groups in this file. I posted in the Slack thread here in testing need the perfect pair, but look at this array spec file and answer the following questions. How should a spec file be named? What require statements are in the top of the file? And I'll let you read the rest of these instead of reading that out loud. So do this in your breakout groups, and I will hop around and try to answer these questions as best as possible, and then we'll come back and talk about them. So many windows to manage for Zoom. Seems impossible sometimes. All right. Welcome back, everyone. So I had you teach RSpec to yourself a little bit, which was probably a frustrating experience for some, if not all. But let's go over some of these questions that I asked in the warm-up together. And hopefully it'll provide more clarity around what RSpec is, syntax, setup, and those sort of things. Breakout room 1, which is Gunnar, Jack, which I assume is short for Jacqueline, and Mark, Y, which I assume is Mark. How should a spec file be named? All right, we'll give you the softballs first. What is particular about a spec file and how should it be named? If one of you want to unmute and share.
I'll share. It is actually not short for Jacqueline, by the way, it's just Jack. But the file should be named first the name of the class or the file that it's testing, and then spec.rb.
Apologize, Jack. Sorry about that. Yes, that's correct. It should be have the underscore spec at the end of the file, and the beginning should normally be the name of the file under test, right? So thanks, Jack, for that. This test file is a little bit confusing because there's no file under test really. We're just like filling in the variable names with how we're supposed to pass it, but we'll get more into the difference later on. All right. Oh, this one, I realize it could be difficult to answer. What requires statements are at the top of the file? Well, here we have something called a spec helper and some other stuff, but normally, in regards to mod 1, you're going to need a require rspec at the top of the file. That one's probably difficult to answer for this one. Just now rspec's getting included here, and rspec is a gem, right? You've probably had to use gem install rspec to get that gem from the internet to be able to use on your computer. And what is a gem? A gem is just code somebody else has written that we get to use in our project, right? By using the require rspec statement and then installing that gem on our computer. All right. Guess what the describe is used for? Guess what the describe here is used for? We'll go to breakout group 2, Jermaine, Lawrence, and Sarah. What is the purpose of describe?
It looks like a class module.
Okay, looks like a class like module. What do you think the purpose of describe is though? Like why do we use it?
Does it tell it what to do?
It sort of tells it what to do. Describe is often used to simply describe what all these tests are testing, right? Here we have a string called arrays, right? And then if you run your test, you can see the describe portion appears right here. If you're looking in the terminal, arrays, test number 1. We could like put anything that's describe block. This is for testing arrays. This might be a little verbose and lengthy, but if we run our test now, this is testing arrays, test 17. So what you put in the describe block in regards to the string is important because when we read the test, right? When we read the test in the terminal after we've run it, we can see what are the group of things that we're testing here, right? In this case, it's arrays. The group of things we're testing is arrays. And what we'll see later is you can have as many describe blocks as you want. Let's say I put a describe block here. And then we run the test again. Oh, sorry. This one is already passing. Let's make this fail again. Let's run this test file again. Arrays, more particular array stuff, right? It'll read the first describe string and then the second. And so we use these describe do end code blocks to group a bunch of similar tests together, right? And so describe literally describes the things that we're testing, the group of things that we're testing. Describe, often used for grouping tests together. That way, when we know when we run our tests, which tests are failing. All right, let's talk about the it blocks. Bring out group 3, Mike, Sammy, and Zachary.
Hey, Bob.
What's up?
Students got their hand up.
Okay. Sorry about that. Let me open up the participants channel. Jermaine, go ahead.
Hey, yeah. So I was just curious about the gems really quickly. I was noticing before, I just wanted to clarify, the bundles don't always stay for every project. You always have to bundle install, so they're never just frequently running. So
without getting, Jermaine, can you post that question in the thread and I can answer it basically? Like on how bundle work. Actually, let's talk about it because it's important. How bundle works is, well, first you need to do gem install bundler to have the bundle command available to you. But how bundle works is you can type in the command bundle, and what it'll do is look at your gem file. It will install RSpec if you don't already have it, and it'll install pry, and it'll install pry by bug for you. We're not going to be using the bundle command a lot in mod 1, but it is important to know. But if you already have the latest up-to-date RSpec gem, it won't install that because it already exists. But that's what bundle does. It looks in your gem file and then installs those gems for you. You can think of the gem file as like a configuration file of what gems get installed when I run the bundle command. Good question. Thank you. Regina, go ahead.
I was just curious because in some of my in all of my RSpec files, I don't have the require RSpec at the top, but it is running fine. Why is that?
Sure. I think that is because via the spec helper, like RSpec is getting included, but also the main reason is when you bundle the gem file, it's like including that in here via the spec helper, but also by installing RSpec. But in all your projects in Mod 1, you'll need to explicitly require RSpec.
Okay, thank you.
Great question. Other questions around describe and how that works and what its purpose is? Jameson, go ahead.
So does describe only add just a tag on the test to describe what it is, or is there other things going underneath the hood?
In regards to functionally, all it does is sort of like add extra like words to the test that gets printed out. But underneath the hood, I'm not exactly sure how it works.
Thank you.
But you do need at least one outer describe block in your test file. You at least need one, like this RSpec describe block. Susie, go ahead.
Yeah, so if you add the require RSpec line to your file, then do you still need to write rspec.describe, or could you do away with that?
Let's see. I assume the test will still run. Yep, because RSpec's already getting included in this file without the require statement. It's getting included like via the spec helper, if that makes any sense, Susie.
Okay. And also, are the notes on the lesson on the curriculum online, are those outdated? Because I feel like they're pointing out a very specific syntax that isn't being really used today. So
we can talk about that later, I guess. Maybe post a specific example and I can clarify if it's outdated or not.
Okay.
Thanks for your question. Lawrence, go ahead.
So you said if we start another, would it be normal to start another rspec.describe if we were testing a different thing than arrays in this same file?
I would use a new file. And also it's just best practice to have a different spec file for each like class or like regular Ruby file that you're testing. That's a good question though. I think if you wanted like more fine grained context, you would just add more describe blocks here.
Okay, I just didn't realize you could call those without the rspec. Thank you.
Sarah, what's your question?
Just really quickly, you keep mentioning that the spec helper is why we don't need to have the require statements at the top. But would we normally have a spec helper under any other circumstance?
You probably will have a spec helper starting in mod 2. So I would not worry about creating a spec helper or what it does right now.
But so for the purposes of our projects and anything that we're writing ourselves, then we would need to put require at the top.
Yep, exactly.
And what would that require statement look like in this case
like
if we didn't have spec helper?
Require our spec.
That's it?
That's it.
Oh, okay, perfect. Thank you so much.
Great question. All right. I'm going to move along here a little bit. Let's talk about these it blocks. What syntax is common in each of these blocks? Let's see. Who was I talking to? Let's just go to room 4 now. Alex, F, and Noah. What is common between each of these it blocks that you see over and over again? Some commonalities, I guess.
I'm seeing that it'll start with the it and then a little string and then do, which I always forget, and then end at the end of it.
Yeah, those are definitely some commonalities, right? We have the it, we have the do and end to indicate this is one test and everything that exists in it. And the string is the thing that describes what that test is doing, basically. Any other commonalities that you found, Noah?
I'll defer to Alex on this one.
Yeah, it's okay. It's okay
Yeah.
if you didn't. Yeah, go ahead.
I mean, they have the same structure with the testing, like the do is the same, the end is the same, the to equals the same.
Yep. And then so it looks like there is like this to equals, thanks, Alex. This to equals syntax or this expect statement in every single it do end block, right? And then so what this expect statement is called in a test is it's called the assertion, basically. We need to assert something is happening, assert against some sort of result. Like normally we do this through expect statement. Right, we expect something to happen, and it's a test for a reason. Like we want to have some sort of assertion. So here in this test, 0, right? Like in every single test, you need an assert statement. And so we're expecting this empty variable, which is assigned to an empty array, to be equal to an empty array. And so the assertion is like part of every test, and you need to use it with the expect syntax here. Otherwise, we wouldn't have a test, right? We need to assert something has happened or something equals something. So the expect part is assertion and exists in every test as well. Okay, we'll do this together. So we're going to unskip test number 2. And then we are going to run our spec file here, or run our test. So what indicates that test number 2 is failing? Well, it has arrays test number 2, right? Which is the string here in the if block. It indicates it's failing because there's a failure or error here. Now, when this happens, what we need to do is read the failure or error and then make that failure or error go away. And so it's saying undefined method underscore 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 for 1, 2, 3 array. And then it says, did you mean, it tries to be helpful. Ruby tries to be helpful and says, did you mean ID? No, we didn't. And then it tells you the line that error is happening on, right? Line 22. So what would we need to type in here to make this pass? Room 5, Molly and Regina. What do we need to change on line 22 to make this test pass? Any guesses?
Actual, oh, hold on. I need to relook at that. The dot's supposed to be there?
No. What?
Oh, so would it be the array 1, 2, 3?
Basically, so how the test works is we expect the value to be 2. So is there a way we can get the number 2 back from this array?
Nums 1?
Nums 1, yeah, using the
Okay.
array, right? This is how we access a index in an array. We can use the array syntax, and we want the thing index at 1. So the number 2 is the thing index at 1. And then so that's how we would make this test pass. Let me save it first. Cool. So that test is passing as well. Great. Thanks for the answer there. One thing I want to continue to highlight is naming your test is really important. Like if we name test 2 something like, if we didn't have a string here at all, it'd be really hard to tell which test is failing, right? So it's important to name your test well. In this case, there's not a lot of context around it. It's just like test number 2, but we'll go into why naming your test is more important in a little bit. And then the way the expect assertion should be structured is we have actual first and expected. Now, this can be a little bit confusing, but expected is what is the result we expected to happen from doing the thing here, right? From doing the thing on line 22. What is the actual result we expected? An actual is the code that's like being run. In this case, it's just the result of calling the first index, accessing the first index on nums. So remember the structure of the expect assertion for 2 equals is expected is the thing here, and the actual is the first thing. Let me try to give you another example. It can add 2 numbers. Okay. So if we're writing our tests, what would we expect the result of adding 2 plus 2 to be in the chat? What would we expect the result of adding 2 plus 2 to be in the chat? We don't use the chat very often. 4, right? So 4 is our expected value from adding 2 plus 2 together. So then how we would write our tests is like we expect the sum to equal our expected value here. Then if we run our test, it should pass, which it does right here. It's hard to see with the little dot, but this is the test that's passing. One other syntax thing you might see is sometimes people will not use parentheses here. in the second portion. I think if it's the literal value, they won't use parentheses. But the test still passed. Now, why is that? You'll see this type of syntax often. Like the actual has a parentheses, but the expected does not. This is pretty common convention. When I talk about convention, it just means the style in code is written that you'll see when people write their RSpec assertions, is they won't add a second parentheses here. But either way you do it is fine. Just know if you ever see this weird thing, it's like you don't need parentheses there. But we will use parentheses.
Bob, can I ask a question before you move on?
Sure.
So in mini test, if we, like, let's say we had put in essentially the wrong answer, we would get expected and then an actual.
Yeah, let's take a look. So let's say for the sum, it's 2 plus 1 for some reason. Then we run our test, we can see how that's failing. So we expected the answer 4, but we actually got 3. And that is how the error will read essentially in our spec.
Great, thanks.
So expected value 4. This doesn't make any sense. This is the exact example we're using because we're just adding 2 numbers together, but that's how the error message will read. Did that answer your question, Lee?
Yeah, it did. I think that in the ways that I had been looking at it, my answers have been a little longer, so it's a little harder to suss out like where's that expected and where is that got. But just knowing the words I'm looking for of expected and got is helpful.
Yeah, cool, awesome. Let's see. Caleb has a question. Go ahead, Caleb.
Hey there. I noticed in some of the tests, you're setting 2 equal to the actual value rather than defining an expected variable. Is there conventions there, or is it just kind of per case basis?
Sure. That is a really great question. What I would say is if your expected value is like more complicated than just a simple like a number, then you probably want to assign it to a variable of some sort. In this case, if you did this, it'd be completely fine. We probably want to use the like expected variable or variable assignment if we want to just make our expectation here, right, or assertion more readable, basically. But I mean, this example is simple enough where it could probably just say expect the sum to equal 4. Expect the sum to equal 4.
Thank you.
And I want to expand on that a little bit. It's like with anything in programming. You want to do a variable assignment if the calculation you're doing is complicated and you want to assign a variable to make your code more readable, right? You're going to want to always do a variable assignment. But we did the extra step here since we're kind of learning of like that this is the actual, this first part, the expect is the actual, to equal the expected value. Just to break that out a little bit more. Susie, did you have a question? I know your hand's not up, it's just unmuted. I think you had it up at some point though. All right, Lawrence, go ahead.
Just for, if we've already defined the variable earlier, like card equals card.new, is it okay to put that variable in the expected, or should we set card to expected and then?
It's fine to put that in expected or even the actual. Let's say you wanted to assert like a certain instance variable on card equals something, then that would be fine. And we'll get into some more examples later that are like similar to how your flashcard project works in regards to setting up your test. All right, this seems like a good breaking point for a 5-minute break. I'll see you here at 1 after the hour. Thank you, 1. All right, welcome back, everyone. So we looked at a specific RSpec file where we were like writing code within the RSpec file to make those specs pass. But normally, we would use RSpec to make sure our application is working the way it's supposed to, right? In flashcards, you hopefully are writing tests, and then you're writing the implementing code to make those tests pass. And then so we are going to go through an example of how you might do that from scratch, right? You don't have any pre-existing code. There's no application code. There are no tests at all. How would we write these things from scratch? Here's one definition I want to highlight. RSpec is just a gem that helps us write tests to ensure our code is working. And what we are going to be showing you is TDD, or test-driven development. TDD stands for test-driven development. It is a process of writing one test, or spec, I guess we'll call it, first. Running the tests. Then making the test pass. Process of writing one spec first, running a test, then making the test pass. It's test-driven development, one test at a time. We're using the test to add behavior or implementation of our code. We're writing the test first. All right, so we're going to do that together. By together, I mean you're going to watch me do it. But if we had a project called Tic-Tac-Toe, hopefully everyone's familiar with the game, we're going to make a lib file and we're going to make a spec folder. Sorry, not file. A lib folder and a spec folder with make dir, as you can see here, or mkdir, make directory. So if you learn the convention of how to create a spec file or the name of it, let's say we want to create a board class for Tic-Tac-Toe, right? Tic-Tac-Toe is played on a board, pieces get placed on it, etc. We probably need some sort of board class to keep track of that thing. If you wanted to create a spec for it, we would do the name of the class or file, which is board, underscore spec.rb. Now, why do we need the underscore spec.rb? Well, when you run the rspec spec command, it looks for files with the underscore spec postfix on the file name. Otherwise, it will not run it. Cool. We have an empty board spec testing file, spec file. First thing we need to do is require our spec, because that is the gem we are using to write our test. In the chat, what is the next thing we would need that we need in every file? We have require rspec in the chat. Let's take a guess. What's the next thing we would need in our spec file? The spec file. That's correct. We would need describe. And the convention is we do describe and the name of the class that we're testing. In this case, it's board. And then we need the do and end block. Describe the board. Do and end block. Now, when we think of the process of test-driven development, the point is to write a test that will add value to our application code. And then since we don't have a board class yet or anything like that, the first test we would write is it can create an instance of the board. Right? We need to be able to create an instance of the board, or basically we're just testing like the existence of a board. It exists. The instance of board exists. To be real specific. Right? We don't have anything in the board class yet, so we need to check for the existence of it. So we would need to create a new board. Then we would expect board I think the syntax is dot is a board to check to see if this board that we're creating here, this board instance, is a instance of the board. In test-driven development, we've written our test. We have well, we'll show you the stages later, the steps. But we've created a new instance of the board, and we expect that board to be an instance of the board class. If we're using test-driven development, next thing we want to do is run our test. We run our tests. We read the error, name error, uninitialized constant board on line number 3. So uninitialized constant board. What does that error mean? Well, it means we don't have a board class yet, right? We don't have a board class. All we have is the spec file. So we would need to require that board class .lib board, which doesn't exist yet. So we need to create a board file, lib board.rb. Split this to the right. Then we will need to create the board class. Now let's run our test again and see if that works. I did mean is a board. Cool. As you can see, I read the error and Ruby was extremely helpful. I need to slow down. It suggested, did you mean is a question mark? And I did mean that, yes. And now the test is passing. Hurrah, we are using test-driven development. I'll answer some questions here in a second once I get through this. Some things I want to highlight about the test is you should generally, as a rule, have one assertion or expectation per test. This is the assertion, and we only have one of them. Now you're probably wondering about the other steps of a test I've listed here. Remember this acronym SEAT. Helps you with creating the steps of the test. Well, we have the assertion, right? It's the expect portion we see on line 9. But we also have S, what's known as the setup for the test. And it is often used to create an instance of the class under test. The setup. Board equals board.new. We need to test things about the board instance, and we cannot do that unless we create one first. And that would sort of be like our setup for the test. Also, in a way, this is our execution for the test. Or like, what are the methods we need to execute? So in this case, the method we're executing is new, right? New is a class method. Don't ask me what class methods are, you'll learn about that later. That exists on any class, right? In this case, it's board. We're creating a new instance of the board. So this is both the like sort of setup portion and execution. Kind of rolled into one here. Using the new method as execution, the setup is we need to create an instance of the board because we want to ask questions about that instance. Like, is it an instance of the board class in this case? So we have the setup and execution, and then the assertion. And then we have an optional step called the teardown phase. What's the teardown phase? Well, the teardown phase is we need to reset maybe the state of tests in between the actual tests themselves. In this case, it doesn't apply since the board instance is locally scoped, right? As you may have learned in the scope lesson, I think you had that, between this do end block, right? We can only access this board variable here, and it only exists there. But teardown might happen when we want to get rid of different instances of the board in between tests. And that's why if you followed the thread and code help channel, we asked you not to do hooks or that sort of thing when creating your instances. All right. I delved too deep into the rabbit hole there. So this is an example of test-driven development. We wrote our tests first. We have a setup and execution here. We have an assertion. We run our tests. We watch it fail. Then we read the error and make the test pass. Make the test pass. All right. Now I will get to questions. Lee, go ahead.
So on line 4 in your spec, you have describe capital board do, not in a string. And so my question is around when you're first creating your spec, is it best practice or is it necessary to do that versus like describe board in a string? Does that make sense?
Yeah, absolutely. I would say it does not matter whether it's a string or we have it like this, where we describe the class basically.
Okay.
I would say it does not matter. It's a convention thing. And what do I mean by convention? Well, convention means let's say you're on a team of developers. What does a team of developers expect this to be written? Is it just a class name or is it in a string? Well, if you do this as a string in one place, you should do it everywhere. It's simply a convention related thing and not important.
So consistency is going to just be the key with that, like choose one, stick to it kind of thing?
Exactly. It's the same reason we go, should we use double quotes or should we use single quotes? As long as it's consistent throughout. It's a stylistic thing, not a syntax thing.
Perfect. Thanks.
Regina has a question. Go ahead. Regina, if you're talking, oh, there you go. Looks like you're unmuted, but I can't hear you. All right, we'll pause on Regina for now. Joe P, go ahead.
Yeah, I just noticed with the expect, you did is a with a question mark. I believe how they had it set up in our project was like to be an instance of. Is there any reason to do one or the other?
No, there's not any. So what Joe P asks is there a difference between is a and like to be an instance of? I'm not really sure to be an instance of how the syntax works exactly, but there isn't a difference. They're both testing like, is the actual thing, the board, is it an instance of the board class, right? So either is fine, whichever syntax you decide to use there. All right, I'm gonna screw this up. Probably.
Natia.
Natia.
Yep. So I have two questions. The first one comes from a standpoint of grading, because I imagine eventually we're going to get graded on this, right? So you've said one assertion per test, right? However, I asked this specific question in code help, and Mike Dow said it is wholly okay to have multiple assertions in a single test. And so if I did that, would I get knocked off on my grading by you, but not by him?
No.
Or how does that work?
You wouldn't. I would say it's probably a difference of opinion. I would say when possible, you should have one assertion per test. Now, with every like quote unquote rule in programming, there is like a reason to break that rule. So the reason why I say like it should be a quote unquote rule to have one assertion per like it block is it forces you to make your tests smaller. And the smaller your tests are, the easier are they to read, and the easier they are to debug. And if we zoom back a little bit, it's like the smaller your methods are that you create, the less lines of code, the easier those methods are to read, right? So in this case, like less is more, I feel like, in that sort of thing. But there might be times where you have multiple expect methods, and I would never dock you for doing that. But I might suggest like if you have multiple expect or assertions, that it probably should be in multiple tests, or your test should be smaller.
And then my second question kind of ties into that, which is this very lively conversation that's being had about hooks. And so I think like I'd be curious to know at some point, and you know, I pointed out like with flashcards, like you're going to get to a point where you have like 5, 6, 7 lines of setup code that you'd have to put in every single test to make the test run eventually. And I'm only so far, so I imagine that might get up to like 10 lines of code for every single test to make the test run, which seems like a lot of additional code to like go through and look at and have in there. And so like, where is the balance in general with that?
All right, let's go down the rabbit hole a little bit and talk about hooks. Now, before we talk about hooks, I want to tell the class, hooks are not important at all for you passing mod 1 or getting promoted to mod 2. Don't need to know hooks, but they are something that exists. Here's why we tell you not to do hooks. Let's say we had something like this. This is not really a specific example of a hook you might use before each, but let's just do this as an example. We're going to say whenever the board variable is called, create a new instance of the board. Maybe that exists there. We're like, cool, sweet, let's use the same instance of the board for every single test. Well, you probably should only do this as a refactor, right? You know the same existence of the board will actually exist in every test. But here's another reason why you wouldn't do a hook. Let's say you had a 113 line test file. Wait, what is board again? Is it? Oh, let me scroll up and find out. What's board? Oh, it's just okay. It's just a new instance of the board. Gotcha. All right. Well, now let me write my test. Wait, what's board again? Oh, it's just a regular new instance of the board. Okay. Sorry, I'm exaggerating here vastly, but if you create a hook or you have some sort of, in this case, what's called a let statement at the top of your file, now I have to continually to scroll up to figure out what is the board? Oh, it's just a regular instance of the board. So when you have pre-existing code like this, like you come into this project and you're looking at this, Now you have to continue to scroll up to see what the instance of board is, and that's why we ask you not to use hooks. If you want a board that you want to use throughout the project or throughout certain code blocks, my suggestion would be to do it within the describe, probably, right? This board is a new instance of the board, and now we can use it throughout different it blocks. That will give you less of that sort of problem. But for now, if you're confused at all by this, which is totally understandable, create a new board every time within the it do end. And as a refactoring exercise, if you wanted to pull that out, that's fine. Natia, did that answer your question?
I think like ultimately, I think the only part that I'd like to like seize on is when you said describe the board within like the describe section. Seems very setup like, but like if my ultimate goal is not to like fail the project. So if I did that so that I didn't have to like describe card 1, describe card 2, describe card 3 in every single test, like would I be docked, or can I do that and get around having to have all of that code in every single test?
If you wanted shared setup, we're not going to dock you for it.
Okay.
It's something you'll eventually need to know how to do, but it is not important for getting promoted to mod 2. One thing I wanted to highlight in tests, which is tricky to see, is we're calling board.new, right? Which is running the new method on a class. So there's a new method that exists on a board class. In every class, there's a new method pretty much, where you can create instances, right? And so when we do board.new here, code here is getting run, right? That is the purpose of a test, is we're running it against our application code. It's harder to see in this example, but I think someone else had a question, but I'll show you how we do it in another one. So the next thing, let's think together as a class. I'll give everyone maybe 60 seconds to think on their own. What is the next thing we might want on a board class for tic-tac-toe? What is the board responsible for when we're thinking about how tic-tac-toe works? What should it keep track of, basically, is the question. Yeah, places on the board, or spaces, yo, as Jameson so eloquently said. So it should have 9 spaces. Might be the name of the next test. So we're doing setup and execution here, sort of both, I guess. Setup. Actually, we're just doing the setup here. So we'll say board equals a new board. And probably should have spaces. So the assertion is we expect board dot spaces, right, to equal, I don't know. We'll just make the data structure an empty array with 9 spaces. 4, 5, 6, 7, 8, 9. I want to make the test pretty, so I'm going to do it like this. With all code, it's good to make it as readable as possible. In this case, I made it like a 3x3 grid, but it's just one single array with empty strings in it, right? So it should have 9 spaces. It's a test. Now with test-driven development, what is the next thing I'm going to do? I've written my tests. I'm saying we expect the board.spaces method to return us an array of 9 empty spaces. We run the test. Thank you, Molly. We run the test. So let's go ahead and do that. Undefined method spaces for board. Awesome. Undefined method spaces for board. So the dummy implementation might be something like this. We're going to create a spaces method. And then we're just going to return an empty array of 9 spaces. Ta-da. That would pass, but we are human beings with brains. So initialize, how you might actually make it pass is say, hey, spaces is going to be, oh boy, I forgot my life, 4, 5, 6, 7, 8, 9. An empty array of 9 spaces by default. And we create a iterator method where we can read those spaces. We can read those spaces. We run our tests again, and it passes. Test-driven development. So we have our setup, we create a board, and our assertion is that the board.spaces is going to be, this is sort of like the setup and execution, but is going to be equal to 9 empty spaces. An array of 9 empty strings, sorry. Any questions on, sorry, I want to highlight this again. On line 15, we're creating a new instance of the board, right? And when we have new, we know that the initialize method gets called as a result of new, right? Initialize method gets called as a result of new. The next thing that's happened is we assign an instance variable spaces to an empty array, sorry, an array with 9 empty strings. And then what we're doing is saying we expect board.spaces. So we're making a method call spaces on the board instance, which happens via the iterator, right? And then so that will return whatever's in the instance variable, which as before is an array with 9 empty strings in it. And we expect that to equal an array with 9 empty strings. I wanted to highlight how the spec code on the left is running our application code on the right. How does iterator work underneath the hood? Probably worth talking about. Having an iterator, I'm going to comment that out, is the same thing as doing this. We create a spaces method that returns us the instance variable that we can then read, right? Iterator is doing that same thing for us. It's creating a method called spaces, and it's reading from the instance variable called spaces. That is what an iterator does for us, right? Just underneath the hood, it's doing this method creation and reading of the instance variable. Instead, we just create iterator. All right, it's 30 after. Let's take a 5-minute break till 35 after. Thanks, 35. Nope. Let's talk a little bit about the pros and cons of TDD, or test-driven development. Well, what's one of the pros? It ensures that our application code works the way it is supposed to, right? Imagine this. You're manually testing your tic-tac-toe game, and every time you do it, you run the program. And then every error you find, you fix your application code. Well, the pros of having tests that are automated. What do I mean by automated? I mean, you can run the spec command. That's like the automated tests to ensure the logic of our code works the way it's supposed to, right? What's another benefit? It forces us to plan things up front, right? We have to think about what methods we want to add to the board class. What are the methods that like belong to the board class even? Should the board class of tic-tac-toe be responsible for checking for a winner? Maybe. No, it shouldn't. Should it be responsible for keeping track of the spaces? Absolutely it should, right? Absolutely it should. So it forces us to plan some things up front, which can be good, right? That way the board doesn't become like this junk drawer where we put like, hey, it checks if there's a winner and it marks spaces and it prints stuff to the console, and we get to better define what the board is responsible for. What are the cons? Maybe volunteer. What would be one of the cons for writing our tests first? Or writing tests at all?
It only tests what we can think of.
It only tests what we can think of. True. Any other cons for writing tests or test-driven development?
It would be slower than just slapping code together.
It is slower than just writing our application code. Right? Let's say you have some CEO who's like, why the hell are we writing tests? You better get that board feature out, Lawrence. It's taking you, why are you writing twice many lines of code for this one thing? So it can feel slower. In the immediate, it's literally twice as slow, right? You're writing twice as many lines of code. But what it helps you is it ensures your application code works the way it's supposed to. So in the long run, right, it actually saves you time. In the long run, it saves you time because you catch errors earlier and more frequently than if you had no tests at all. But yes, it's absolutely slower than just writing the application code. I want to go back to this point. We can only test what we can think of, right? One argument for not writing your test first is you have no idea what you are trying to build. Or you are using a new technology. What do I mean by using new technology? Let's say you're writing something in JavaScript. Would you really write JavaScript tests first for your JavaScript, even though it's a new language? Probably not. You would probably just play around with it, right, to see how it works. So when there's like an unknown of the thing you're building, then it might make sense to write your application code first and then write tests afterwards. But at the Turing School of Software Design, we're going to be dogmatic. Always write a test first, please. Always write a test first, please. If you can't, that's totally fine and understandable, but we're going to highly encourage you to always write a test first. The other pro of testing is it provides us documentation, right? When we look at this, we can say, oh, I know what the board class is doing. We can create an instance of it, and it should have 9 spaces, which might be a little bit easier as code gets more complicated than to just read the code itself. You can see the things the board does by looking at these it strings. Dana's question, go ahead.
So the other thing I guess that I'm thinking is that it might not catch like inconsistencies, where if you have like board in like as a string, like throughout half or the whole thing, and then have like it different somewhere else, it wouldn't catch that. Or if you're doing something like not totally efficient, like if you're using the def initialize instead of the adder reader, it wouldn't like catch that to tell you that there's a better way you could be doing it, right?
Yes, it would not. That is a good point. But this is where our human brains come in, right? Let's say you bring up a very good point, Dane. Let's say instead of this adder reader method, we wrote def spaces returns spaces. Let's run our test to make sure that still works. Great, our test pass, we're done. Let's move on to the next thing. Record scratch, pump the brakes. There's a concept in testing called red-green refactor, which means watch the test fail, red. Watch it pass, or write the implementing code. This is similar to TDD. They're both like processes. Watch it pass, green, and refactor. We can safely refactor our code now if it needs to be refactored, because we have a test that asserts that board.spaces is going to return an array of 9 empty strings. How do we refactor safely? We comment out the code that already exists. And then we write a refactor. Why do we comment out the code that already exists? Because we know it works. We don't want to get rid of it. Let's say Dane comes along, save the day. Hey, Bob, why don't you use an reader instead? Great idea. Let's try an reader. We've made a refactor. We run our test again, right? Because the tests ensure that our code's working the way it's supposed to. It works, and then we delete the previously existing code. That is how we are able to refactor safely, right? The behavior of spaces returning an array of 9 empty strings already works. So let's comment that out, write our refactor, which is an reader in this case, and then run our test again to make sure it works. Right? Tests are a safeguard to make sure our code is working the way it's supposed to. Okay. Let's use our developer brains again. We have spaces, we have the existence of the board. What is the next test we can write? To add value to our application. When you think about a board, right? Everyone take 60 seconds to themselves and think of 1 or 2 tests we can write next that would add value to our application. All right, I see some good answers in the chat. Some good answers in the chat. 1, we want to be able to mark the board and change the spaces array. Also, I think Susie, this is really important. What happens if a space is already marked with an X arrow? Right? We want to be able to mark the board, but also, how do we test what happens if a space is already marked with the X arrow? We try to mark that space again. Well, something should happen. So what you are going to do, oh shoot, I should have copied this code. What you're going to do is write the test for this. I know you don't have anything to clone down, but I will send you this board spec file and this board file as it exists. You're going to write this test for this on your own. So what you need to think about is setup, execution, and assertion. What do we expect to happen as a result of calling a certain method? I'm going to send you this. And select-
Which method specifically are we doing? Are all of those at the bottom that you just commented? Or just that
this-
top one?
Just the top one, but also you need to write a separate test for this edge case.
Okay.
We'll talk about what edge case is, but like, let's say there's already a space here, right? And someone wants to also, like, O wants to go in the space, or X wants to go there again. What should happen?
Okay, thank you.
Yep. So this is the test we're writing. We want to be able to mark the board and change the spaces. All right. Right. Sorry. One thing I want to talk about when it comes to we're testing our actual methods themselves. The convention is, let's say the method we're testing is called mark. Well, our spec convention is when we're testing a method, have a describe block for the method under test. This little pound sign means an instance variable. We're testing an instance variable. And then you write your test here, basically. Remember, describe block groups tests that all have to do with one thing together. You'll probably need to write 2 tests for this. But just start with one. Can we mark the board and change the space? And then write the implementing code. Let me copy this over. This is, that's the board spec file. And this is the board file. Sorry, I meant to have this in a repo beforehand. But there you go. Take some time and do your best to write the tests. Use the raise hand feature in Zoom if you need help. This lesson's going to run a little bit over, but yeah, I'll put you into your breakout groups now and do your best to write the test for these.